Okay, so this is going to be something to do with algebra part. So I'm just trying to tell you on certain topics, which is going to be something to do with number systems. I remember some of the teachers telling me that you need to know something about certain aspects in number system. I was told that you need some part in number system. So I thought I will go with what all are basically needed for in the number system topic. So with this, I will make a start. So as far as the contents are concerned, I'm planning to do something with real numbers, with rationals and irrationals, and certain concepts and quadratic equations. And then I will go for arithmetic progression part also. Okay. So with the introduction, I'm starting with rationals and irrationals. As you all are aware, children are so finding it so difficult to classify rationals and irrationals. So it's better we tell them about initially, for whatever be the class, whether it is 9th or 10th or whatever be it, it is very essential that we tell them about everything right from the beginning, because this being pandemic year, 2-3 years, they have lost everything. They don't know anything. So start with basic concepts like going ahead with what is rational, its definition. How do you classify the rationals in terms of decimals? So tell them all that. Let us not think that they know it and they've learned it in lower classes. So just to tell them rationals are like this. It has to be having a it should be in P by Q form, everything, all definitions pertaining to its decimals. We need to tell them its decimal part will be this. As you all are aware, I needn't have to give all those definitions. Tell them what it is. How can it be in terms of decimals? Then when you come to irrationals, introduced surds, they are all these are not there in our textbook, but we have to tell them what are they. We need to say what is a surd, because what we need to give them is some basic knowledge about all these things. Even if it is not there in the textbook, I feel it is better we go one step ahead to tell them about what it is, and as it is, you tell them to explore if they want to know more in detail about it. So when it comes to search, we may have to tell about what are mixed search, pure search, and what are the various operations. See, even when they come to higher classes like 9th and 10th, when there are two irrational factors, they don't know to add. So we have to tell them the basic requirements that is needed to add. So all that we will have to be very, very careful in giving informations, though it is not available. You know, class 9 textbook is so simple that it doesn't have too much of content, but we cannot give up. We have to tell them about what it is. We should tell them about what is a surd. We should tell them about how do we add to irrationals. We have to tell them how to rationalize the denominator, because every answer that you come across in trigonometry and in many other cases would involve irrational denominator. We need to rationalize and get the answers. Basically, they lack all these things. So what we feel is we need to strengthen even in class 9 and 10th level also we need, because since 3 years they have not been learning anything. So let us give them a lot of explanation about what is it actually. So request all of you to introduce all these topics before we start analyzing or going into any topic. So in real numbers topic, we need to say what are rationals and irrationals in terms of its decimals, in terms of its definition. We should also tell them about what is a surd. I will come in detail about all those things as and when I progress. Then we should also say what are proper surds, I mean pure surds, mixed surds, and various operations on surds like addition, subtraction, multiplication, and rationalizing irrational denominator. All these we need to tell them to and how to simplify the search. So for this, we can go in for classifications like this. We can start saying about what we are supposed to say. Like we can say real numbers classified into rationals and irrationals. Then again, rationals can be classified as integers and non-integers. Okay. So again, when you talk of integers, integers are whole numbers and negative integers. Please tell them all those things, because when we just keep telling integer, 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 nobody will be in a position to recapture all those things. So when you say integers, you tell them that they will be whole numbers and negative integers. Again, when you say whole numbers, you tell them that 0 is a whole number and rest all are natural numbers. So that way you can give them a clear explanation by classifying numbers this way. And when you go to irrational part, you can say it in terms of decimals, non-terminating, non-recurring decimals. When it comes to rational part, you can say either it will be terminating or it will be non-terminating and recurring decimals. So if you're going to classify numbers based on a chart like this, thing like this, it would be registered in their minds in a very, very effective manner. So request you all to classify numbers before you take up the concept of real numbers. And this would enable the children to understand and have more of clarity. So just to start with real numbers, go with dividing it into rationals and irrationals. Rational, in turn, you can divide it into integers and non-integers. Integers, again, in terms, it can be subdivided into whole numbers and negative integers. Whole number, in turn, can be written as a 0 and natural numbers. So this way, if you are going to proceed, it will be more effective. Children will find it more effective, and they will also find it to be more interesting. They will be able to interlink between the topics. That is the intention behind asking you all to give explanation like this as far as the classification of numbers are concerned. So please give proper, let's all give proper explanation about this before we go ahead with analyzing rationals and irrationals. So let's not stick on only to rationals and irrationals. Instead, we will go to basics, come to that part slowly. So that is how we should be in a position to proceed with. And I hope I have made it clear, teachers. Is it okay? Am I audible? Am I clear, teachers? Please tell me.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Now we will slowly move on to search. So when it goes to search, irrationals are search. But there are certain, you call it as a search only when you cannot determine its values. So that way we may have to make it clear to them. We may have to tell them that we call it as a search when its value cannot be exactly determined. In the sense, it cannot be reduced to a whole number or an integer. An irrational number is supposed to be a search when it cannot be expressed, when its value cannot be a whole number or an integer. That we have to insist. Otherwise, they will be confused. We should tell them. So only if you tell them that, they will understand that, oh, this is what it is. It has to be this way and things like that. Okay. So please make them understand the definition for search, and then slowly move on to different types of search. Maybe you can say pure search, mixed search. So give them a lot of examples. Give them a lot of examples. You need to, you take one topic. Let us take one topic per day, and let us see to it that it is given a lot of explanation. Let us not concentrate on more than one concept per day. You take real numbers. Let it be a search on one day with all the concepts relevant to search, though it is not there in the textbook. Let them have a strong foundation on that, and then let us move on slowly to something else which is there in the textbook. Basically, strong foundation has to be given. Strengthen the basics and then proceed with what is there in the textbook. Things will flow very easily if we are going to do it that way. So types of search, you can say pure search, give a lot of examples. Say what is a mixed search. Mixed search can be also given with a lot of examples. How to convert a pure search in its mixed form, that can also be explained. Give them, it's all available, very clearly available in many sources. Maybe you can even see it in the Google and give them a lot of practice exercises once the concept is introduced. I know all of us are doing it, but then I thought I will bring this into your minds just because it is not available in the textbook of class 9. It directly goes with dealing with addition, subtraction, multiplication, rationalization of denominators, and it goes off to exponents. But before, this is all not there in class 8 level also, if I'm right. So we need to at some stage introduce all those concepts into their minds. So go ahead with search definition, give them all types of search, tell them about pure and mixed search, and then go for simplification of search. So as far as simplification of search are concerned, addition and subtraction would involve one rule. So we will introduce that rule in their minds. We will tell them what is a radical. We will tell them what is a radicand. We will tell them what is that index, and all that has to be brought into their minds. Only if they are aware of all these things, they will be very successful in proceeding with when it comes to doing sums. And then when they have to do addition and subtraction, it involves a particular rule. So give them that rule. Tell them that irrational factors that has got to be the same whenever we need to simplify by adding and subtracting. And tell them the order of the search should be the same when we have to perform a product and quotient. These all, when this, even when they come to higher classes like 11th and 12th, they tend to commit a lot of mistakes in addition and subtractions of rationals. The reason is they are not exposed to a lot of exercises. So give them a lot of practice exercises. Once the concept is introduced, it's better we give them a lot of practice exercises like which I've mentioned over here. Cube root of 3 into 6th root of 5 means they should be in a position to see that the orders are made the same and then the product is determined. Simply, they will write the answer as cube root of 3 into 5, 15. They make that mistake. The reason behind is they are not said about the order or the rule, the order that need to be changed over there. The basic rules has to be inculcated into their minds. Tell them what are the basic rules that need to be taken care of when it comes to simplification of search. Kindly give them a lot of practice exercises also after the concept is introduced. Yes, teachers. So as far as searches are concerned, you need to go with simplification of search. Though it is not there in the textbook, though it doesn't cover, it isn't covered in the syllabus, it's wise that we go ahead with giving them such concepts. Tell them what is a radical, what is a radicand, what is an index. All these has got to be definitely inculcated, induced into their minds, because they commit blunders when it comes to doing sums in higher levels. So give them the basic definitions right from lower class itself. Then coming to rationalization of denominator. That concept of rationalization of denominator, you give sums, they will be ready to do it. But you tell them to find out the rationalizing factor of something, they will not be able to do it. Because we are drilling them with a lot of questions on rationalization of denominator. Because it is available in the textbook. We tell them to rationalize a binomial denominator. And we go out of interest, there are some of us who will also go for trinomial denominators, though it is not included in the syllabus. But above all these, if you are going to tell them to have, to find out the rationalization factor, they are finding it difficult. Rationalizing factor is something very, very important that they should know. It is not available in our textbooks. So kindly introduce that rationalizing factor concept. So when the product of two radical expressions is free from radicals, then we say that the two expressions are rational factors of each other. Say, for instance, if you want to find out the rationalizing factor of root 5, we are going to say root 5 along with one root 5 will be making it a rational expression. So we say that root 5 is the rational factor of root 5. So same way we can do it with root 15 means we will say it is root of again it is going to be root 50. So if you have something like where you can multiply with some factor to make it a rational number, we are going to say that that is the rationalizing factor, right? So if you take root 8, we are going to say that as 2 root 2. Is it not? So we are going to say, if you ask the child what is the rationalizing factor of root 8, let them not say that it is root 8. You make them convert it into a pure mixed cert and then tell them to find out the RF. So rationalizing factor has to be taken into consideration and given a lot of practice exercises. Please give them a lot of practice exercises so that they don't miss out that basic concept. They lose such concepts. They tend to make a lot of mistakes when they go to higher level. So though it is not available in the textbooks, I feel it is our bound duty to inculcate, induce, introduce such concepts as they miss all this drastically, and that is very, very important. So again, as I have been telling you, in search, we have to give a lot of practice exercises because it's not as easy as we think. It requires a lot of training. It requires a lot of drilling also. I should say drilling. We need to drill the children. We need to give them a lot of drilling exercises so that they will find it very simple and easy when it comes to doing it in the higher level. Okay. Yes, teachers, anything to be clarified in this concept of rationalization of denominator? I believe all of us are doing it. but for some certain things which need to be introduced here and there, which is not available in the textbook, but very, very essential for the higher classes. So kindly make a note of all this. I know we are doing it still. If in case it's missing also, we will have to do it. Okay. So again, when it comes to number line, I know in class 9, we have a number line concept. Geometrical representations of rationals, all of us are training it in lower classes. Still again, inserting some rationals in between two rationals, all that is possible when you represent it in the number line and show them. So give them a lot of ideas about how to represent rationals in number line. And then move on to irrationals in number line. That is again there in class 9. It can be posed as an activity also. Activity-based questions, these can all be. So you can tell them to draw number lines by, they will find it very interesting if we make them do something and get their values, measuring it with a scale, and then observing their values, which is standard basically given by the as a table. So say for instance, we are going to tell them to practice, tell them to construct root 2. Okay, taking proper units in mind and ask them to find the value of root 2. Obviously, they will be able to find out that it's 1.4. And if you're going to tell them in a form of a table that root 2 is 1.4, and if they have achieved it, they would think that, okay, this is true. They will be very happy to accept it. That's the purpose of all these things. So let us make them understand that everything is practically proved. And it's not something like somebody has given those values and it has to be accepted. As we all are aware that nothing in mathematics is accepted. It has to be proved. It has to be proved. It cannot be accepted. Nothing can be generalized. Nothing can be accepted as a rote memory. It has to be proved. Let us give them chances to prove that. So these number lines would enable them to prove the values of some irrationals also. So let us also give them a lot of practice exercises to make them understand how do we obtain the values of certain things like root 2, root 3, root 5, simple things, root 10. Go to the extent of root 10 and then go to some root 17. We can easily make them understand that 17 is closer to 4 point something because it is closer to root 16. So if we give them that ideas, they will be very happy to understand and they will never forget. There is no possibility of them to forget at all. That is the basic thing. If you instead keep telling them root 2 is this, root 3 is this, root 5 is this, root 7 is this, root 10 is this, root 15 is this, root 16 is this, it will not be, effective. Instead, if we make them do some number lines like this and ask them to analyze and see what we are saying is the same as what they have obtained, they will never, never, never forget. That is the intention behind telling them to do such type of activities. So number line concept, please make them do lot of number lines. Though we don't find time, it's okay. Every now and then give them a lot of practice exercises. Give them a lot of homework. Tell them, you take your time, give them in a weekend. Explore, come back, tell me, are you happy? Yes, they will be happy. And you all are aware of this. I hope it is there. I think it is there in class 9 textbook also. The spiral square root. Give them as an activity. They will be able to say what kind of picture you get. They will happily say it's a peacock. It can be an art integrated project. Tell them, see, it looks like a peacock. Wonderfully, you have done it. Tell them to go to the extent of making such type of beautiful sketches. So in a way, we are introducing, or we are inculcating that in their minds, and we are also motivating them to do some artwork, which is going to be a sort of project which could be evaluated by us. We can tell children, see, we are in a position to get something like this, which is, a wonderful part of this topic. Please go ahead with doing this. See that you are in a position to understand things in a better manner. Give them a lot of such exposures, and they will find it very interesting. So this way we can make them understand about how to go about making the number line concepts more clear, to have clarity about irrationals and things like that. Then moving on to class 10 concepts, Euclid's dilemma and all that. It's all concerned with finding HCF and all that. And it also goes with division algorithm. dividend is equal to divisor into quotient plus remainder. So that way we are going to tell about Euclid's this thing, no? We can in a way, you can correlate. You can say that given a positive integer AB, there exists whole, instead of saying all that, you can even say HCF is, this division algorithm has nothing but to do with the basic division thing that, what is the dividend is equal to divisor into quotient plus remainder. Associate that with this. So that association would make them understand this Euclid's division lemma in a better manner. Give them, we are learning it in lower classes. Tell them, you all know you are learning it. That is extended further by a person called Euclid's. And his lemma is nothing but the basic thing that we have learned, which will make you have more clarity of what it is. Same thing to do with fundamental theorem of arithmetic. Bring in all prime factors. Prime factors is the basic thing which is there in fundamental theorem of arithmetic. So though they have learned in class 8, though they have learned in lower classes like 6, 7, 8, we bring these concepts in class 10 only to recollect what they have learned and make it more stronger as and when they proceed to higher classes. So fundamental theorem of arithmetic, when we start, we bring in the concept of prime factors. That way we are going to bring in product of primes and what is a co-prime. Bring everything. Let's not restrict ourselves only to writing the prime factors. Let's go one step ahead to find out which all are co-primes, because again we are going to prove root 2 is an irrational, root 3 is an irrational. All of a sudden we are going to say that P by P and Q are co-primes. They will be wondering what is a co-prime. So give them all these basic things before you go to that. So again, I am telling you, since 2-3 years we have missed out so many things. It's better we tell with basic things like this. Go from basics. Let's start going from basics, because they have lost a lot in their lower classes. In classes 6, 7, and 8, what they had learned in the online classes is just not enough for them, and they need to do a lot more. Kindly let us all be very, very practical in telling them all that they have learned in lower classes. Tell them, let us tell them that we need to have all these things in our mind, because if we have forgotten also, it's better we refresh and come to that level. Because once you want to bring in that root 2 is an irrational, root 3 is an irrational and things, I'm sure teachers, you all will be agreeing with me if I'm going to say that we need to tell them once again about what are co-primes. And some children have the tendency to say one is a prime. Though they know that it is not right, they commit that mistake. So let us keep telling them even in this level. We will tell them, children, I know you all are aware of it, but still I am bringing it to your notice. In case you have such wrong intention, please understand that this is it. You have learned in lower classes still. Let us, if by saying this, one child or 1 or 2 children, if they do not know also, they will try to understand, oh, okay, this is it. Let us try to be coming to that level of, like, we are only trying to recall and tell them out. I know you all are doing it, teachers, but still when it comes to my mind, I'm sharing it with you. And if you have any other thing that need to be shared with me, kindly tell me. I can also listen to you so that I can also introduce this with my students. So as far as any suggestion, teachers, you can interrupt in between. I'm ready to listen to you. Let it not be one way. You can tell me if you have anything to say as far as the prime factors and all these are concerned. If you don't have, I can go to the next concept of HCF LCM. Here I was told that some of our children generally have a problem when it comes to word problems. And we can also give some extra information to them that LCM by HCF will always be a whole number. Tell them all those things, because we are giving them what is LCM. We are telling them about what is HCF, but they don't understand that LCM will involve all the multiples, and it will be the least of all the common multiples, and HCF will be the highest of all the common factors. So that way they always get a lot of confusion in this. It's something like this. You can post something, you can give some pictures like this where you can tell them about how do you differentiate LCM and HCF. Maybe we can say them to list all the factors of the two numbers. And then we can say that there are some factors which are common. Those common ones are supposed to be the HCF. Product of those common ones would be the HCF. Apart from them, there are some factors on both sides which could be also taken into account to say that the product of the common factors followed by the uncommon factors would be the LCM. So that way we can give them more of clarity. Instead of doing it by L method and something like this, if you are going to post some pictures like this and tell them that, it would be very easy for us if you understand it this way. I think it would be more easier for them. Maybe we can also say LCM by HCF will always be a whole number. It cannot be a decimal. And you can also give the relationship between HCF and LCM. That way we are going to make children understand that HCF and LCM is not something very, very tough. It is going to be very simple if you know basically what it's. So when we want to say something about HCF and LCM, we can say it this way. HCF is the product of all common factors, whereas LCM is the product of all common factors followed by uncommon factors. If you are going to say it this way, children will find it very easy to understand. And you can also cite some examples without numbers. Maybe we can say something like this: a power 4 into b power 6. Find the LCM of this, and this means they will understand that common factors a power 4 into b power 4 will be the HCF, and bringing in the remaining uncommon factors will be making it as LCM. So bring it that way. And then we can start giving them some explanation on word problems. So as far as word problems are concerned, maybe we can give them some idea about what, how can you differentiate HCF and LCM as far as word problems are concerned. They are totally confused. They will always keep asking, Miss, how can we find out if what is needed is HCF or what is needed is LCM? Repeatedly, they ask these questions. Haven't they asked you, teachers? I think teachers who had been handling classes 9 and 10 would be hearing this from students. They will repeatedly ask, Miss, how do we know if what we have to find out is HCF or LCM? Is there anybody who had come across such questions from students? Have you heard students asking such questions?
Yeah, ma'am. They in the word problem they won't mention HCF or LCM. They might ask what is the least number, what is the like that. They used to utilize some different words. They might get confused sometimes, ma'am. It happens.
But what do you say, Ramya madam, to them? What do you tell them?
So the how to understand, the way of understanding the question is very important. That least, somewhat they will mention the least or lower or less, somewhat related to that word, they will definitely mention for sure. So we need, normally they used to explain HCF, LCM. Sometimes they might forget the definition of LCM. Least, common, multiple. The multiple, least, they forgot the words totally. They just know LCM, LCM. Somewhat if you ask them what is the definition of LCM, they might think for some time. They know the sum, they know the calculation, everything, but they forgot the definition. So like that, we have to insist them each and every time. We have to tell, not only LCM, we have to explain it. Now we are going to find multiple like that.
So what we can tell them is, I don't know. I feel we need to tell the children to judge the question. If the answer that we need to obtain is going to be greater than or lesser than the given data, we can give them a simple hint like this. From the question, let them judge if the answer that they need to get should be greater than or lesser than the given data. First, let them analyze that. If the answer has to be greater than the given data, they should understand that what they have to determine is LCM. And if the answer that they are supposed to get, if they judge the answer to be lesser than the given data, let them understand that it has to be HCF. If we are going to give this idea into their minds, I feel they will be in a position to clearly understand if what has to be determined is going to be HCF or LCM. So let us give such small tips and ideas in their mind. As you say, we can judge, and the way you understand the question, Ramya madam, as you said, the way you understand the question is very, very important. From the question, we can judge if what we have to obtain as the answer has to be greater than the given data or lesser than the given data. With that concept in mind, we will be in a position to say what we have to determine is going to be HCF or LCM. That would be the best way of making them understand. I have given 1 or 2 illustrations here. Probably we can tell them to understand. We need to supplement everywhere with illustrations. Illustrations are very, very important. So I don't know, I had slides, but slides are not picking up in mind. That's why I had to go to a PDF to have everything. Anyways, so first question was Ravi and Shika drive around a circular sports field. Ravi takes 16 minutes to take 1 round, while Shika completes the round in 20 minutes. If both start from same points at the same time and go in the same direction, after how much time will they meet at the starting point? The question is like this. So obviously, I don't know, as you have been telling, if a child has to go about meeting it for the next time, they will meet at the starting point, means obviously they have to cover many rounds. So to go cover many rounds, the time taken would be more than the actual time which they have taken for 1 round. So the child should understand that it has got to be LCM, right? Understood, teachers? Am I clear? I don't know if I'm making
Yeah, ma'am. Yeah, ma'am. It's clear.
Any other clarification or any other way of proceeding with this? I feel this would be a very easy way of commuting to children, as they will also understand that it is very easy for them to differentiate, to find out if what has to be determined is this or that. Any other suggestion, if you can give me, I think, and if that sounds to be more easier, we can implement. Anybody else, teachers? Any other teacher who would like to come forward with this? Same way, I've got another one illustration for HCF also. A merchant has 120 liters of oil of one kind, 180 liters of another, and 240 liters of third kind. He wants to send the oil by filling the 3 kinds of oil in tins of equal capacity. What should be the greatest capacity of such a tin? So let us not give them a chance that greatest means it's HCF, least means it's LCM. Never we should try to say that. But then the child will have to understand that 120 liters should be the minimum amount for all the 3 cases, even if it has to be equal quantity. Okay, so it has to be a value which should be either lesser than or equal to each of these. So something which has to be either lesser than or equal to will have to be HCF. So we can say that it has to be HCF. So probably we can give them some simple tips like this to go ahead with finding out if the given sum has to be in terms of HCF or LCM. Something like we can give them a lot of ideas. Yes, Ramya, madam. Ramya?
Yeah, I'm just noting down, ma'am.
Okay. Anybody else can come forward with any other idea of giving them clarity about this HCF and LCM? I would like to listen. Somebody else, if somebody else, Aarti ma'am, or anybody else, anybody for that ma'am, Shanmugam sir, anybody. Let's all find out if there is any other source by means of which we can give them clarity. If somebody could go ahead giving me some suggestions. No? Is this okay then? Is this okay, teachers?
Yes.
Yeah, ma'am.
Thank you, ma'am. Thank you. Now we will go to the next topic, quadratic equations. So linear equations was done by ma'am yesterday, and we can go ahead with doing introducing some concepts in quadratic equations. As all of us are aware, we have introduced the concept of degree and all that. We are going to classify equations based on the degrees only. So go ahead, let us go ahead giving them all the general form of a linear equation, general form of a quadratic equation. Based on the degree, we'll have the number of roots. Here, let us bring in a differentiation between zeros and roots. We need to bring over here. We need to say where does the word zero come in and where does the word root come in. So 0 comes in polynomials. Of course, polynomials is totally different from equations. So we can try to classify. Generally children tend to commit mistakes saying that these are zeros, those are roots. We need to give them some clarity about what are zeros and what are the roots. So zeros comes when the polynomial is exactly equated to. So 0 of a polynomial is that value of the variable when the entire polynomial is equated to 0. Again, roots comes when the equation is solved and the number of roots depends on the degree of the equation. So whether it is quadratic or cubic equations, again, it depends on the degree. So we have to slowly tell them about the degree, and we should give them the general expression for a quadratic equation. Here again, I would like to insist that we have to mention that a quadratic equation is an equation of the form ax squared plus bx plus c equal to 0, where a is not equal to 0. That's very, very important. Some of us tend to miss all these things. That has to be insisted. You know, the child will have to, only then the child will understand where to reject and where to maintain the values. I will come to it in course of time. So the purpose of telling all this is only because if we don't insist on certain things in mathematics, it would lead to misconception. So in quadratic equation, we need to say an equation of the form ax squared plus bx plus c equal to 0, where a is not equal to 0 is a quadratic equation. And because the degree of this equation is 2, you will have 2 roots. And we can slowly, ma'am has already discussed about all this parabolas and other things yesterday. So graphical form of linear equation is a straight line graph. Maybe you will have one more session where ma'am will be, Lasita ma'am will be giving us a lot of GeoGebra concepts on all these parabolas and all other things. We can go in depth on all those cases in course of time in future. Now, I will just to say that these are certain things that has to be conveyed to children as far as quadratic equations are concerned. So as far as solving part is concerned, we need to understand, we need to make children understand about all the various ways of solving quadratic equations. We can tell them quadratic equations can be solved by any method of their choice. Generally, board doesn't insist on any particular method, but I understand this time they had asked for one method. It's fine, but as long as they are aware of finding out the roots, there should not be any problem. We can just tell them to learn various ways of solving a quadratic equation. Classify them this way, tell them, and give them such type of pictures which would be getting registered in their minds. Tell them nature of roots means put them such a picture and make them understand. Instead of giving us notes, give it this way. And here is, I have cited an example for nature of roots. All these concepts, I know all of us are aware. But then why I said this was, see, there is an example question which I've cited over here. So many had gone wrong with all these type of questions. That's why I'm trying to tell you all these things, children. I don't know. If you have anything else to convey also, please tell me so that all of us can be benefited out of it. There was a question in a paper which was something like this. If the quadratic equation px squared minus 2 root 5 px plus 15 is equal to 0 as equal roots, then find the value of p. All of them have understood that b squared minus 4ac is equal to 0 because that's a condition for equal roots. And then they have obtained the value of p with 2. They have obtained p as 3 and p as 0. But then they have failed to reject p as 0 because they have not understood the basic concept of the definition of quadratic equation. See, when it is p times x squared, when we have insisted on a not equal to 0, when a becomes 0, it has to be rejected. And the child has not realized that. So just like that, though they know, they are tending to miss marks. So it is at this stage that we will have to make the child understand that a should never be equal to 0. For such purposes only, I told you it's better we tell the child the proper definition to make them understand that that has to be taken care of. So this I thought I will bring this into the discussion part because they tend to commit mistakes on such type of questions. So let us try to make them aware of such things. And then we can also give them some simple tips to solve word problems. We can tell them, if we are going to give them such tips, it will be applied by them just like that. There will be a free flow of application. They will never, tend to think for a very long time. So give some simple tips to approach word problems. Say, for instance, tip number 1. Supposing they are telling you that the product of 3 consecutive numbers are something, and the child must be in a position to understand that it would be easy if they take x minus 1, x and x plus 1. Instead, if they take x plus 1 and x plus 2 also, it's possible. Nobody says no, but then it might not be as easy as this. So let's give them some simple tips like this. So if there are 3 consecutive numbers, Let us tell them to be x minus 1, x and x plus 1. And there again, there might be something like 3 consecutive odd numbers, 3 consecutive even numbers. So under such circumstances, let us say, if it is going to be consecutive odd numbers, it has to be 2x plus 1, 2x plus 3, 2x plus 5. And if it has got to be even numbers, let's take it as 2x minus 2, 2x and 2x plus 2. Give them such simple tips so that they will never go wrong. Let us do it. When we do this, the child will also be developing some interest to go ahead with doing word problems otherwise they will have a fear for it. Word problem, sight of word problem creates a lot of fear in their mind. To avoid such fears, we will introduce all these things. Again, that there are some questions where you have some 2-digit number questions. There again, you tell them these are the general forms where x will be the tens place, y in units place means it is 10x plus y, and reverse means it becomes 10y plus x. But then insist on them to say which is units place and which is tens place. Let's not be very telling them it's 10x plus y, 10y plus x. Instead, we should say 10x means x is the tens place, plus y means y is in the units place. So you keep telling them all these things, they will never tend to commit mistakes as and when they come across word problems. Same way upstream, downstream, ma'am said yesterday. So upstream, downstream questions, put them in a lot of pictures like this to tell them that upstream means it is speed of stream minus the speed of boat. Downstream means it is speed of stream plus the speed of boat. So going against and going towards that concept yesterday as ma'am was discussing. We will come across taking such type of questions. So this type of small hints and tips given to children would help them to approach word problems in a very easier manner. Okay, teachers. And anything to ask me at this stage, if you have, you can tell me, or I will proceed further. Now, what are the common mistakes? I thought I will list out some common mistakes which I have observed. If you have done anything, observed anything also, you can tell me. Generally, in all these, roots can be both positive and negative. But when it comes to word problems, take care to see that we reject the roots whichever is not applicable. Rejection is must when it comes to root being negative when it comes to word problems. And common error is when it comes to discriminant, in nature of roots, they tend to take square root of b squared minus 4ac. Let us tell them that it is not so. And if possible, let us try to derive formula and make them understand. Derivation of formula will give them more of clarity. I feel it's better we derive the formula and tell them so that they will never forget. So if possible, if time permits, we can also derive the formula and give them a lot of. I'll go to arithmetic progression. Now, again, this is again a very new topic, very new to the children in class 10. They are not used to sequences and all that. It starts here. Children have never come across one such a topic at all till class 10. And it's such an interesting topic and everyone will love it, as you all are aware. And so before we introduce itself, if we are going to give them a lot of exposures, I think they will love it all the more. So I thought we will start it like this. We will give some patterns in nature. We'll ask children to observe the patterns. We'll tell them, look at the sunflower. It has a pattern. This thing, all petals have a pattern arranged. Look at a honeycomb. It has a pattern. Hexagonal patterns everywhere. Go for a corn. Go for the steps in a ladder. What do you observe in all such things in nature? We observe that everything has a pattern. We will automatically get all this from children. They will say, it keeps registered in their mind if you're going to proceed like this. Then we will slowly move on to patterns and mathematics, numbers. Consider there are some numbers which can be given like this. It can be positive, it can be negative, it can be the same, it can be raised to some powers. Where all you observe something common, we can slowly bring in. In the first case, you can say that it is a sequence of numbers maintaining a difference of 1. In the next case, we are observing that it maintains a difference of 4. Following, it maintains a difference of 0. Again, it is a pattern. Whereas in the next case, it doesn't maintain a sequence at all. Like in the sense you say 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, and so on. It doesn't have some common property in its platform. So there are cases where you can maintain some properties, and there are some cases where those properties cannot be maintained. And then slowly we can introduce a concept of AP. So such cases where we find out some common differences among the terms is supposed to be an arithmetic progression. So if we start with nature, slowly moving on with some examples, then introducing the definition, it will be all the more effective for the children. I know it is not possible in an offline class, but then we can picturize and show. We can give examples. We can say, have you seen the corns, the seeds in the corn? Have you seen the, the cells in the honeycomb? What about the petals in a sunflower? What do you observe in all these cases in nature? Bring those things to their mind if you are not able to visualize. Then slowly bring in some number patterns like this. Then move on to definition of AP. We can say what it is after we give so many citing examples and then coming to the definition part. Once we come to the definition part, then we can say about what is A, what is D, what is N, and what are the conditions that we need to keep in mind. We can say A can be positive, A can be negative, A can be a fraction, a decimal. D can be positive, negative, a fraction as a decimal. Only thing which cannot be a fraction or a decimal or negative is N, the number of terms. Slowly, if we bring in that concept in their mind and slowly start with derivation part, please let us all prove everything. Let us not directly say AN is equal to A plus N minus 1 into D. We need to at all stages give them a lot of justifications. So let us tell them, when patterns are observed, we will observe the first term, the difference between the terms and the number of terms. Finally, we will come to what is AN. Let us not directly give AN is equal to A plus N minus 1 into D. Instead, let's go ahead with giving them steps in the sequence, so the children will also be very much appreciating the topic and loving to do the sums based on these topics. So I know we are doing it, still it's better to go ahead like this. And then again, coming to selection of terms of an AP. Here again, like this consecutive terms, I would like to insist on, if the number of terms is going to be 3 in number, let us say the middle term could be chosen as A, the previous term is A minus D, and the next term will be A plus D. If the number of terms are going to be even, you cannot go with the same procedure. So if the number of terms are going to be even, then we might choose the middle 2 terms to be A minus D and A plus D, and keep on multiplying it on both sides depending on the numbers. So if you cannot take the middle term as A if the number of terms are going to be even in number. So if the number of terms are odd in number, we will take the middle term as A and previous and next as A minus D and A plus D. If they are even, then we may not be able to take the middle term as A. We may have to take the middle 2 terms as A minus D and A plus D, and we may have to come across the rest of the terms to be A minus 3D, A plus 3D, A minus 5D, A plus 5D, and so on, expanded that way. Again, if the number of terms are going to be 5, we can go by the same procedure. So odd numbers means middle term can be chosen as A. Even numbers means we will choose the middle terms as A minus D and A plus D and keep expanding it forward. Is that okay, teachers?
Okay.
Yes. Thank you. Thank you. And now, so whenever you take anything to do with any chapter for that matter, at a stage we must be in a position to say how much it is applicable in day-to-day life. One child might ask, what am I going to gain by learning HCF? What am I going to gain by learning AP? I don't think we can just like that say for scoring marks we are learning. No, we have to say why we are learning. Everything should have some application in daily life. So give them such type of questions where AP could be applied in day-to-day life. You can go to their level to give such type of questions. Grandpa gives you some pocket money, and tells you to put it in your piggy bank. And if suddenly grandpa is asking, I have given, if you have 10,000 rupees, in how many months, every month grandfather is giving you some 100 rupees. And finally, after over a period of time, it becomes 10,000 rupees. How many months did it take for you to go up to that 10,000 rupees? So there the child would understand that they can apply AP. So we will make the child understand that anything and everything that you learn in mathematics is applicable in day-to-day life. Only if you tell them that application of all these things, they will also get an interest to learn such things. So give them such ideas and tell them to learn, tell them to understand what is the application of it. And before you start any topic, it is better to give them some prerequisite knowledge. So for proving sums in AP, we need to basically understand what all are the basic things required for doing sums in it. So that has to be covered. Like you need to know how to solve quadratic equations. So first we should take quadratic equations solving. Only if that is strengthened, the child will be in a position to do sums in AP. So prerequisites has to be taken care of whenever you come across. Then again, you have sum of n terms. All that is again there in our textbook. And one basic thing that I have observed is the child is not in a position to differentiate what is AN and what is SN. When are we to find out AN and when are we to find SN? They don't know. You give a question, all of a sudden finished. They are put in a lot of fickle mind that they are not in a position to say with what they have to determine is an AN or an SN. So there again, we have to tell them that clarity has to be given. If that part is not taken care of, how much ever they learn, how much ever they understand, they fail to apply. And so please let us try to make them how to understand how to differentiate an AN and an SN. If we are going to give them about which we do it for HCF and LCM, if you are going to tell them the ways by means of which we can differentiate AN and SN, it's going to be a very simple task for them to apply it and get it done. So application of AN, SN, and what is its role in day-to-day life? You keep telling them SN, what is its role in day-to-day life? Give them a lot of examples. We need a huge amount granted for some organizations to school to be distributed to high achievers, prize distribution. We set some common difference between the first prize would be this much amount. Second prize must have some 500 rupees difference. So third prize should be another 500 rupees difference. Here we apply AP, tell them. Orally we can tell them. This way, giving them proper usage of the concept would help them to approach it with great interest. They will also develop some interest to understand. Only nowadays, children are also business minded, unless until you tell them that this is needed for this purpose, they are not ready to accept. They need to understand that the purpose of learning is this. If you are not going to tell them, they won't be ready to understand. So engage only, they understand everything. Most of their minds are set to understand as to what they know to differentiate what is needed and what is not needed. At least in 10th level, they know. So if you are going to give them a proper catch, you tell them that this is needed for this purpose, then they will develop some interest in doing it. So let us give them what is its application in day-to-day life. That part has to be taken care of. Finally, in short, in AP, what I would like to say is whenever you post questions on AP, you just to tell them all the simple tips. Ask them to list all the values of A, D, and N before starting the solution. Tell them to always remember that N should be greater than 0. It has to be positive. Okay, N cannot be 0 also. It should be greater than 0. And then for an SN problem, they should be in a position to understand that they will be arriving at a quadratic equation which has to be solved to obtain 2 roots. And if needed, we may have to reject one of the 2 roots. And is any problem in AP an AN problem or an SN problem, that has to be analyzed and done. That part also, please give them clarity. And that is all that I want to say about these 3 topics.